Hello, my name is Peter Groves-Williams. I'm a technical specialist with SNOMED International, and this talk is going to be an introduction to SNOMED CT with FHIR. Has anyone here been to a SNOMED talk before? Okay, welcome back. The rest of you, not to worry. We are going to start from the very beginning. SNOMED International is a not-for-profit organization. We're supported by 49 member countries. Jamaica joined last year, so I'm really hoping we're going to have a conference there at some point. And in fact, our conference this year is going to be in South Korea, which I'm very excited about. We add about 900 concepts, and SNOMED CT is published monthly. Some small number of countries also publish their SNOMED extensions monthly, but mostly they release every 6 months. SNOMED CT is the most comprehensive and precise clinical terminology in the world. SNOMED CT is first and foremost an ontology, which means that it is a set of concepts along with their related properties and relationships between those concepts. SNOMED CT is a polyhierarchy, or directed acyclic graph, and that means that concepts can have more than one parent, several parents, and that means they can be many different things, types of thing at the same time, and that reflects the real world. So it's not like a classification system like ICD, where a code has to be in one particular category at a time. SNOMED CT has a comprehensive scope. It contains concepts describing disorders, body structures, medicines, procedures, devices, organisms, and substances. So there's the potential to code everything you need into an electronic patient health record. Well, except maybe lab test results, but we'll come to that as well. It's computable for analytics and decision-making, and that would be particularly important in a case like pharmacovigilance, where we need to have alerts in real time. And because SNOMED is hierarchical, that means you can work at whatever level of granularity you're interested in. So very fine-grained specific concepts for patient-level records, or with abstract groupers for analytics and population-level queries. And it's self-describing. Most things in SNOMED, the different types of descriptions, the attribute types, even the structure of the reference sets themselves are described using SNOMED concepts. And that means that it's computable at runtime. As SNOMED changes, your programs will be able to react to those, find out what's changed, and make allowance for that. As well as in our hierarchy, the rules around which attributes you can use with which sorts of concepts are described using our machine-readable concept model, and again, that is computable. Okay, so here are our learning objectives for today. If at the end of this session you feel you have not obtained these objectives, or if you feel I have not explained them sufficiently, please do come and speak to me, or catch me anytime this week. Firstly, how do terminology and information models work together? In this case, SNOMED CT being our terminology and FHIR being our implementation, our information model. An analogy would be like, SNOMED CT is like having a dictionary, and it's important to have a wide vocabulary so you can be really precise about what it is you're communicating. But there needs to be structure, there needs to be a grammar, otherwise we just have a jumble of words. We wouldn't be able to work out the subject, say, of a sentence. So we wouldn't know, are we talking about the patient or a family history? And we wouldn't know, are we talking that the patient has a disease or might have a disease, or have we in fact proved that they don't have it? SNOMED CT and FHIR work best together when they play to their strengths, and SNOMED acts as a controlled vocabulary and leverages the structure that's applied to it through FHIR. Right, let's have a look at the structure of SNOMED. Us developers love a good class diagram. Everything in SNOMED is a type of component. All components have an identifier, an effective time, which shows when they last changed, a module ID that shows who's responsible for them, and an active flag. Nothing that's been published in SNOMED is ever deleted, it's just marked as inactive. Component is an abstract class. The concrete classes are description, concept, and relationship, and there are also ref set members, which we'll come to as well. You might be able to see from the cardinality on this diagram that a concept must have at least 2 descriptions and at least 1 relationship showing what its parent is. So let's look at each of those in turn, starting with the concept. Concepts have unique identifiers, numeric, up to 18 digits in length, and a concept is bound to a fully specified name, or FSN. The meaning of the concept is taken primarily from the FSN, even more so than the attributes. Attributes can change over time, but a fully specified name generally will not. Descriptions. Each description belongs to one concept, and a concept will have several descriptions, each one versioned independently. There are 3 different types of descriptions: fully specified names, FSNs, synonyms, and text definitions, which can be up to 4,000 characters in length. Concepts must have at least an FSN and a preferred term. A preferred term in any dialect is expressed via a language reference set, and that's the one you would probably see in the user interface of some application. Relationships. Each concept is associated to other concepts by a set of relationships. Relationships express defining characteristics of the concept, and again, they're components, so they're versioned independently and have an active flag. Relationships come in 2 main flavors. They can either be ISA, which means they define the hierarchy, the parent-child relationships, or they're about some other property of the concept, in which case we'd call them attributes. Relationships can also be grouped together. So this is what appendectomy looks like as a model diagram. And there's a lot of detail in here that you would learn about if you came to one of our foundation courses. But just to pick out a few features. Although I said appendectomy, the box in the top left shows the fully specified name, excision of appendix. And that's because FSNs have to be unique. They're unambiguous. And to ensure that they are, we will always have a semantic tag, which is in brackets. So there you can see that's a type of procedure. The 3 lines in the circle there show that this concept is sufficiently defined in a logical sense. And what that means is, when I have any other concept, which I say is a procedure, and it has these same 2 relationships, procedure site of appendix and a method of excision, grouped together, those will be inferred to be a type of appendectomy. And these inferences are made using a computer programmer called a classifier. The last thing is that open circle there at the bottom shows that those 2 relationships have been grouped together, so they're relevant. If we had some other feature of the concept, maybe an excision on a different body structure as part of the same procedure, those would be grouped together, so you know which method goes along with which procedure site. Okay, reference sets. There are 21 types of reference sets defined in our specification, and the structure is extremely flexible. So you can read about those in our technical implementation guide. Here are the 3 which are used most often. A simple reference set is just a subset, or in FHIR terms, a value set. It's just a collection of concepts. Simple maps are used for all sorts of things, most notably in our historic replacement mechanism and for language reference sets. When a simple map won't cut it, then we have complex maps, and those allow us to define extra rules. For example, it might make a difference to the mapping if the patient is female or male, which SNOMED generally wouldn't worry about, but ICD might do. So that covers our first 2 learning objectives. Moving on to the third. As well as the concepts themselves, SNOMED features a family of languages, and compositional grammar underpins all of them. Compositional grammar allows you to specify the modeling of a concept in a really concise and parsable way, and that's how you could express a concepts module in both pre- and post-coordination. Pre-coordination are the concepts that we publish, and post-coordination would allow you to define new concepts potentially at runtime. So these 3 languages build up, so most of what's used in expression in SNOMED compositional grammar, that will appear in expression constraint language, and we need expression constraint language to define our templates. SNOMED template language is a companion to the machine-readable concept model. It allows you to get really specific about what type of concept you're modeling and which attributes you'd expect to find there. So for example, if I'm modeling a bronchoscopy, then I'll say that the finding site, the body structure, has to be a type of lung structure, and the device used has to be a type of bronchoscope. So it's much more specific than the machine-readable concept model. So we use template language in our authoring platform for adding new concepts and also in our quality initiative, which has been running since April 2018, but that is a whole different talk in its own right. Another feature of template language is it's not just about the attribute modeling. It also allows us to find slots for the fully specified names and preferred terms. So for example, if you've picked an attribute value to put in one of your slots there, the preferred term for that part will appear in the full FSN for the concept that you're creating. Expression constraint language is, I think, the most powerful feature of SNOMED CT. ECL gets used all over the place. In our template language, machine-readable concept model, reporting, and our specification of ref sets, and we'll see shortly how it can be used in FHIR value sets. The table here shows the symbols that we use 95% of the time. We also have operators for ancestors, immediate parent-child, a reverse operator, and cardinality. Documentation for that can be found in our document library, or you could go to snomed.org/ECL. Where the descendants operator is particularly useful is in the maintenance of FHIR value sets. So instead of having to redefine or maintain your FHIR value set, if it's defined with something like a descendants operator, if a new concept gets added into your hierarchy, when we just reevaluate that concept will get added in. The caret or hat symbol is particularly useful as well, because if you've defined your value set just to be the expansion of an existing reference set, then you don't need to say any more than that, and you're only doing your maintenance in one place. Right. Here is an example of some ECL. And what I've said here is ECL is really the equivalent of SQL. It allows us to make a selection based on a set of criteria. So here I'm saying I would like all descendants of medicinal product that have some sort of has ingredient attribute type, and I want that to be equal to caffeine. And I've said that I want a presentation strength because I want a drug that I can actually prescribe and not some abstract grouper. Oh, I should say, the descriptions between the pipe symbols, those are completely optional. They're just there to make it human readable. So unless you've memorized 368,000 10-digit numbers, most people like to see those in there. So that's SNOMED CT as our modeling language and logical model. In terms of our support for FHIR, we've also made a terminology server available. That's free to use on our GitHub site. Snowstorm is not a commercial product, although we do try to react to issues raised on GitHub, and it's available as a Docker container. The big news for Snowstorm last year that we added support for other code systems. So our FHIR API is based on the Happy library. So basically anything that you can load with Happy, you can now load in using Snowstorm, but most obviously that would be ICD-10 and LOINC. Snowstorm X, as you might guess, is the experimental arm of Snowstorm. That's also there. And at the moment, we're trying out support for storing and classifying post-coordinated expressions in there. Snowstorm-lite is a lightweight version of Snowstorm, and that was written by my colleague Kai Cooley. For developing nations, it will run on a laptop with under a gig of memory. So Snowstorm provides the back-end data store and business rules for a lot of our applications. Here you can see the authoring platform that our clinical terminologists use to maintain SNOMED. I picked it because it's our most colorful application. We also have a browser which gets used far more often, but it's not quite as pretty. So here you can see a new feature, well, relatively new. I'll give you the date on that. But in the green boxes, these are concrete values. So although I said a relationship has a source as a concept, the type of the relationship will be a concept, and the target was a concept. In the case of a concrete value, your target is going to be an actual real number. We used to implement this with concepts defining each numbers, but there's actually an awful lot of numbers, so we needed an awful lot of concepts. Actually, fewer than you think. We only needed 500. But we've got rid of all those now, and we have proper numbers in there. And that's really powerful for something like ECL, because I can say, return me all the drugs that have more than one ingredient, or return me drugs that have less than 100 milligrams of aspirin. And that's useful if you're looking for blood thinning agents rather than painkillers, for example. Okay, so that's pretty much everything I wanted to say purely about Snowstorm and SNOMED CT. Are there any questions of clarification before we move on? Yeah, there's a question. Marita, do you have the mic? There's a question down there.
Does Snowstorm support also very simple FHIR value sets and code systems, like small flat ones?
Oh yeah, absolutely. No, it's a terminology server with full FHIR, well, full, I shouldn't say full. It has as much FHIR support as we've been asked to present in it so far.
Okay, great.
Okay. Any others?
So when you say...
Oh, sorry, could you wait for the mic?
Oh. So obviously it's been built for authoring and browsing SNOMED.
Yes.
But you also mentioned that it supports other code systems?
Yes, and in fact the support for those will be mainly through the FHIR API, because we don't have a need for those. Snowstorm has a native API, which we use for our internal systems. And we need that because we need to maintain SNOMED.
Okay.
The FHIR API is more about a read-only operation. So when we're working externally, we make that available.
Okay. Just to be clear, it doesn't support OWL?
OWL?
Yeah.
OWL. We store our stated relationships in an OWL format. Not as an entire OWL file, they're in little snippets.
Okay.
I will come on to that in a later slide.
All right, thank you.
But for the FHIR API, no, there's no support for OWL. Okay, here are the main FHIR terminology resources and operations that we're going to look at today. Dion McMurtry has a talk tomorrow afternoon about the same time, and I'm pretty sure he's going to look at each one of those in detail. So I'm just going to pick out the ones that have particular features that are interesting when we're talking about working with SNOMED CT. Right, code system, lookup operation. Here what we're saying is, I've got this SNOMED code, tell me more about it. In example 1 here, in red, let's see if I can get my cursor on that, there's my system parameter saying that this is a SNOMED code, and in green, there is the code itself. So I can click through on that, and that is COVID-19, and we get back some information. We didn't specify a version, so we're getting the most recent one coming back there, which is the June edition. In the second example, I've specified the full version URI. And if I was to go back to those heady, carefree days of the July 2019 edition, in fact, I'd get a 404 there because that's the same code, and we didn't know about COVID-19 back then. In the last example, I'm requesting an additional property. The FHIR specification has a page for listing particular properties that can be requested on SNOMED concepts, the module ID, whether the concept is sufficiently defined in a logical sense, but the most interesting property is the normal form, and that allows you to see how a concept has been modeled, its attributes. So let's drill down on that. Now this is SNOMED compositional grammar, and I've chosen a more complex example here so I can show it off a bit. But an expression like this could be as simple as just the parent of the concept. Here again, you can see the concrete values. Those show up with a bit of type information. The hash there tells you that it's a number. Because it could be that we have a strength of a drug that runs into the millions. And so we need to be able to tell the difference between that and a SNOMED identifier. And again, between the pipe symbols, we have a text representation that is not required for machine reading. So these can get really tight, really concise. Now, something that's great for interoperability in FHIR is that it doesn't make much of a distinction about what country module a concept has come from. A SNOMED concept is a SNOMED concept. And we've taken that philosophy on board with our URI specification. So URIs, as was said in a previous talk, do not have to be resolvable, but it does seem like good manners to make them go somewhere because they look an awful lot like URLs. So if I was to click through on that one, it does not matter which module a concept has come from. If we have that concept anywhere on our terminology server, we will look it up and find it. So you don't need to know what module your concept is in before you request it. So here we can see the server is telling you, oh, I actually found that in the US edition. And the most recent version there was in March. And if we scroll down, where's it down there? That is American cheese, so that's in the US edition. That's my favorite American concept. Now, if we couldn't find that concept, there's actually some namespace information embedded in the middle of that identifier. And so we can tell you where that concept came from in terms of who owns the namespace that that has been assigned to. So if we haven't got that extension loaded onto our terminology server, we'll still be able to give you something back. The HTTP accept headers play a part in this lookup. And because I'm coming from a browser, I would normally get it would think I was working in that environment, looking for some HTML back, and it would send me to our public browser rather than a FHIR JSON object. So I've forced the format to come back as FHIR in that case. Right, value set and the expand operation. So this is to say, ask the server to evaluate whatever content or rules the composed element states against a particular code system and list all of the codes that satisfy these rules. So Dion will cover this, no doubt, in more detail tomorrow. So I wanted to focus just on a particular strength of SNOMED CT, which is in internationalization and multiple language support. So here, I've told the server to ignore whatever version is in the value set itself and force it to expand against, that's actually the module ID for the Swedish edition. And I've said in the green line there, I'd like the display language to come back firstly as Swedish, and if we can't find a Swedish term, then we'll fall back to the English. And we're going to filter that down on pollen as a text filter. So expand that, and there are our Swedish terms coming back that relate to pollen. Because I haven't specified an effective time, I'm going to get back the most recent version of the Swedish edition from that. Right, implicit value sets. Now this is, in my mind, the coolest feature of FHIR because it uses my favorite feature of SNOMED CT, which is ECL. Your applications do not need to predefine and maintain a value set on a FHIR terminology server. You can just define a selection at runtime, and that's especially useful for creating context-sensitive user interfaces. You could say, I want all the concepts that are a type of this code, or I want all concepts that are members of this reference set, or you could go full ECL, which is what I've done here. And what I'm saying is I would like all types of procedure where some sort of procedure site, so that might be a direct or indirect procedure site, is some sort of heart structure. And in that first line there, I've taken out the descriptions there, so you see how tight these things can get. So in the first example there, I'd get 1,700 procedures back, which is just far too many to scroll through. So in the second example, let's say the surgeon has started typing, he wants to do an MRI. So we start filtering on that, and in that case, we'll get back 26 there, which is a far more reasonable number. Right, so where all this SNOMED and FHIR together is getting to is, how are we going to make your medical application responsive, context-sensitive, and therefore clinically safe? So we've written a demo application, which you can have a look at yourself at snomed.org.ui, and that shows us some best practice. Now, I've tried this as a live demo before, and it's too small to see, or it's either too small, or if you make it big enough to see, then you can't see everything on the screen. So I've just cheated a bit and put it up as a screenshot. But I brought up the developer's tools console, and the point I want to make there is, and you can try this out for yourself, the box there where I've written appendectomy, that is looking for a procedure. So when I start typing, we see an API call being made to a FHIR server there, and it asks for an expansion. It knows that I'm looking for a procedure, so it puts in not a call to a predefined value set, but to an implicit value set, where I've said I want some sort of procedure, and I'm going to filter that on whatever the user has started typing. So that makes your application relevant to where the user is, and it can change at runtime depending on the conditions on the page. The laterality field there is quite interesting because SNOMED is actually better at laterality than you might think. Now, I've said I want an appendicectomy, and hopefully most of us know we only have one of those. It's not lateralizable. So the laterality box will be grayed out in that case. If I said biopsy of lung, and I didn't specify which lung it was, then the laterality box would be available. I could say left, right, or both. And if I'd chosen biopsy of left lung, then the laterality box would be pre-filled with left, and then I wouldn't be able to modify that field. So that protects us from anyone having a slip of a mouse and entering in some confusing data. Right, so what's new with SNOMED CT? Working forward in time, if you haven't looked at SNOMED CT in the last 5 years, you'll have missed that we moved from stating relationships individually to expressing them as AL axioms, which was sort of your question there, which lets us do some really powerful description logics like role chaining, defining attributes as transitive, and GCIs, general concept inclusion, which all gives us better classification results. Concrete values we added in July 2021, and in February 22, we moved from producing the international edition every 6 months to every month. This month, we're adding component annotations, starting gently there with attribution. So if a concept has been donated to us by a third party, we'll have a mark for that. Something we're currently doing a consultation on is increasing the size of our descriptions. So we need that for medicines that have multiple ingredients and for multivalence vaccines. Some extensions are already using additional relationships for things like the price of a medicine. These are non-defining, don't play a part in classification, and aren't inherited. But it allows us to do something really cool, which is use ECL immediately. So unlike annotations, where you couldn't do this, but in an additional relationship, we could say something like, find me all medicines that cost more than $100 per box. Snowstorm-lite, I mentioned earlier, can run in under a gig of memory, and our URI resolution has been improved, so we can now look up a description ID. But what we really need to get on and do is a URI for an ECL statement. The last 2 points have their own slides. So ECL now features a whole range of filters. You can filter on a concept's description or pretty much any property of a component, like its module ID or effective time. Something that's really useful when working with historical patient records, which might contain concepts which have since become inactivated, is we now have a mechanism for adding those back into your value set. A couple of interesting looking operators that have been specified but not implemented, unless maybe Onto server has done that, I must check with Cicero, are the top and bottom operator. The top operator is useful for working out what major hierarchy a concept's in, and a bottom operator will let you identify the leaf nodes or most defined concepts in your set. Now, a good use case for that is if you held your data as very fine-grained data, the most specific concept you could find on a patient, but for your transmission, you were limited to some subset of SNOMED CT. The example of that would be the International Patient Summary. Then the bottom operator would let you find the closest concept, which is one of your ancestors, but is part of that set. So what's been happening with Regenstrief and LOINC? Well, we, that is SNOMED International and Regenstrief teams together, are making LOINC terms available in a SNOMED CT format as an extension to the International Edition. Last time I gave this talk, I said that we'd done a pilot of 100 terms. We then moved on to a technical preview where we were able to put 24,000 terms, and we're now targeting our 1.0 release for LOINC 2.78. So something that's part of that work, but we're going to see in other projects, is the support for alternate identifiers, and that's the LOINC code there would be an example of that. Now, this is not a map. What we're saying is, in fact, this is the same entity being expressed in an alternate format. And we're looking at the NUVA ontology of vaccines and also NPU, which was a product that LOINC originally grew out of. So here is a reminder of what we've covered today. The main message I'd like you to take away is that SNOMED and FHIR need each other to communicate meaning, a controlled, precise terminology combined with a universally agreed information model. And also that the specific features of SNOMED CT that we can take advantage of in FHIR to reduce maintenance of value sets and provide context-sensitive sets based on a position and attributes in a hierarchy. Okay, heading towards our last slide now, just a shout out to our SNOMED on FHIR working group. We meet every second Tuesday at 2000 hours, a very reasonable time in the US afternoon and rather unfashionably early if you're in Australia. We also have a call every fourth Wednesday at 1000 hours UTC to better suit Europe and Asia. So I have discussion there led by some great experts, and absolutely anybody is welcome to join that call. We're there for the benefit of anyone who's interested in using SNOMED and FHIR together. Okay, and that concludes what I planned to say about SNOMED and FHIR. I'd be delighted to answer any questions.
So on the slide where you were showing the SNOMED code for COVID-19,
Yes.
and yes, and you said that, so without a version, it comes back with the most current version.
Yes.
But then on the next link on that slide,
I said that it wouldn't come back because when I say I want to expand or look at the 2019 version, that concept did not exist at that time in SNOMED CT.
I see. For some reason, I thought it would have been something different in 2019. So no, it is, I was just thinking you don't like reuse codes from the past.
Never.
Okay.
That would be horribly
was like,
confusing.
okay.
We have a replacement
Good to
mechanism.
confirm.
Yes, we have a replacement mechanism. So when you inactivate a code, you give a reason for it, and that's held in a simple map. That's an example of that. And you say, if I've inactivated it because it's a duplicate, then what is it a duplicate with? Or does it need to be replaced? Is it ambiguous? In which case, which two concepts might you need to choose between and say, could it be this one or could it be that one? So a replacement is not always safe. In the case of a duplicate, yes, absolutely. There's only one thing it's duplicated with. But in the case of it being ambiguous, you might be given a set that you have to say, well, which one did I actually mean? And that'll depend on the text that the physician has selected.
Yes. Have you used the Sparkle query language at all with the SNOMED L version? And do you have opinions on how that compares to the ECL?
It is used. People have used it in our organization. I haven't personally, so I couldn't comment on it.
Okay.
Thanks.
Regarding expanding value sets with Snowstorm, in the example you showed, it was using ECL in the URL.
Yes.
I mostly encountered value sets defined in FHIR with like a different syntax. It's in the value set compose element. There's like a property.
Yes, you can say children of this concept.
Yes, but eventually it's a JSON. I mean, it's a resource. Is there a way to expand these kinds of value sets? Like,
absolutely. If you've defined your value set as that, Snowstorm and any other terminology server should.
So how would the API call look? I mean, would I post this value set to the Snowstorm server?
You can even do that. You could post the JSON and ask for it to be expanded at the same time.
All right.
Which seems like a lot of work.
Yes, but if that's what I have in hand.
Normally, I mean, that's the sort of the advantage of value sets is that people specify them because they want to cut down on what it is. I mean, it's all very well for me to say you can choose any procedure, but that assumes that someone's capable of performing that procedure. The point of a value set is to say, no, we're only going to do these 100 procedures, and I'm not going to change that. So what I'm saying here about being able to update it at runtime, you don't necessarily want your value sets to change at runtime because that assumes someone can deal with that at the other end. So yeah, traditional value sets where you define them and then you say, I want a list of my value sets. Oh, there's the one I want. And then implement that very much have their place as well.
All right, thank you.
When somebody deploys this, either in like a medical application, EHR, hospital system, whatever, do they tend to use like a standalone server, terminology server that understands SNOMED? Do they embed this in an existing system? Are they like proxying to a terminology server? I'm just trying to get a better sense of how people actually use terminology servers like this.
I'm sure everything you've listed gets done somewhere. I hope that people will implement their own terminology server. That's certainly what we see. We also see people who try to implement their applications against our browser in their live environment, and we very much ask people not to do that. We get absolutely hammered on a daily basis. And we also see a lot of scraping going on. Like someone has tried to go through our browser and take every SNOMED code. You can just download it. You don't need to make 100 million HTTP calls to find this data.
Great talk, thank you. Well, I'm a FHIR lover, and SNOMED is one of my favorites as well. Really happy to see them working together.
Yes, very much.
I happen to be invited to their SNOMED International to Mental Health Informatics Working Group, and there's really no FHIR during our sessions. I'm just a little bit confused to see if you might have any insights on, I guess that's sort of like rate of acceptance of FHIR across SNOMED groups and different specialties. Yeah. If it's not politically correct question, you can ignore it.
No, it's a good question.
Okay.
It did take a little while for it to be recognized in the senior management of our company that FHIR was something we needed to take very seriously. For a while, there was a sort of new kid on the block feeling about it. And then just at some point, maybe 6 or 7 years ago, it was like, no, this is really, everybody's going this way. We need to support this. And at that point, we added the Happy API. And because we don't need this internally, because we're maintaining SNOMED, the operations aren't really there in FHIR for actually adding new concepts and changing them at runtime. We need something different. But yeah, it is very much recognized that we need to be interacting with FHIR, that is the future, that everybody's using it. And for example, the Snowstorm-lite server that was developed, that will only work in FHIR now. It was developed more recently, so that is very much our direction. I'm glad to hear that you're on that working group. I hope you can provide a FHIR perspective to that group. Okay.
Thank you for the talk. I'm liking this slide here on implicit value sets. Can you specify the underlying code system version?
Oh yeah, absolutely, yeah. That's just a parameter I didn't need at the time. But yes, you could expand against anything that you know to be on the server. Obviously, you can go to the server and say, what code system versions have you got? Now, the calls I made there, where was my concept? Code system lookup. Yeah, so here, for example, in the version parameter that I've said here is a particular module, which is an extension. I've said go and find that one. But there's another sort of, another way of going about that. You can say, go and find me all the code system versions that are there, and they will have an identifier, and these are like the instance value of that. So in that case, you get your code systems, you say which one it is you're interested in, it'll have an identifier, and then you do your lookup at that point. So you don't need to pass that parameter through. And on code, I mean, Dion will cover all of this tomorrow, but you can search for your code systems as well. You can say, show me one that has that was issued by Sweden or Germany or whatever. Do we need to watch our time? We've got a couple of minutes left. Marita, there's a lady here.
Thank you. I'm just connecting a few comments that you made throughout your topic around hoping to see everyone would implement their own terminology server to take advantage of some of these advanced complexities, and comments around if you don't supply a module or an addition, that as long as those modules are part of your terminology server, there should be the capability of knowing where the code comes from. I'm curious if it is very common that you're seeing folks who deploy their own terminology servers, include every single module, every single national edition that's available, and if that's more computationally like taxing?
No, nobody's doing that that I've heard of. So generally, people will choose a terminology server which is a commercially supported product, right? They need quick turnaround for that, and they have a particular jurisdiction they're interested in. So only really SNOMED International has got that. Although having said that, did Graham put everything into his server? He was trying to load a lot for a while.
It has the capability of having it,
Yes.
but it doesn't have.
So Graham's server is capable of doing it, but doesn't necessarily. It's a lot of overhead.
Yeah.
And
It probably would, if we tried to have everything in there, I imagine it would not be scalable.
yeah.
We haven't tried it.
So what happens then?
Do we need the mic back, Marita? What happens? Well, you can go to SNOMED International and find the code that you're interested in. I mean,
Is that the workflow? So basically, if you get an error, if you say, oh, I can't find what module, then the next step in the workflow is go to the SNOMED International
that would be
terminology
a
server.
great idea. I hope
Okay.
people are doing that.
Okay.
I don't know how else you'd find it, because it's got to be somewhere.
I was just thinking of one other thing that maybe, I don't think you mentioned, at least I didn't hear it, but on the FHIR terminology world, now we have basically the ecosystem strategy where you can nominate various servers for handling particular, additions and versions and all that. So you could have your own local server for your own jurisdiction, but then you could hand off to Snowstorm for any other SNOMED that you didn't recognize or things like that. You can do a lot of things now within that FHIR terminology service space.
Yeah. Thanks, Rob. Have we got time? Okay. That wraps things up. Right. Thank you very much, everyone, for coming today. Great to see you. Thank you.